Imagine you never had to tell AI, now fix this error, now run this test, now update this ticket, now do it again. Instead, you get to give it one goal. Find the highest priority bug, fix it, test the solution, document what happened, and keep going until the work is done. That shift from prompting the AI at every single step to actually designing the system that prompts AI is called loop engineering. And some of the people building today's leading AI coding tools are saying this is how they work now. In the next 10 minutes, I'm going to explain to you what loop engineering is, how loop engineering actually works, where you can use it, and the one piece that determines whether your AI creates real value or it just makes mistakes faster. Hi, I'm Sadie. I'm an AI researcher and executive who has worked in AI for over 15 years. And today, I'm going to show you exactly what loop engineering is, how it actually works, and how you can use it. Most people are still using AI like a vending machine. They put a prompt in, get an answer, and then put in another prompt. That can be useful, but if you are still doing that, you are missing out on the power of AI. Loop engineering asks a different question. Can I design a system that knows what to do next without waiting for me? So here's the easiest way to understand this evolution. Prompt engineering is telling the AI what to do. Write this function. Context engineering is giving it the information and the environment it needs. Here's the code base, the documentation, the business requirements, and the constraints. Loop engineering is building the operating system around AI. Find the next task, complete it, check your work, record what happened, and continue until the goal has been met. Prompt engineering improves instructions. Context engineering improves what the AI knows. And loop engineering improves how the work continues. Okay, let's make this real. Today, you might open a bug tracker, find the most important issues, paste it into AI, ask AI to investigate it, then ask it to create the fix, tell it to run the test, review the results, and then tell it to create a pull request. Every step of the way depends on you. In a loop, the system does it all. It checks the bug track. It selects the highest priority issues. It creates an isolated workspace. It investigates the problem. It writes the function. It runs the code. It runs the test. It's a separate review checker that works. It revises and fixes when necessary, submits a pull request, and then finds the next issue. You are no longer managing every instruction. You are designing the rules of the job. So what does a useful loop need? It needs 6 things. First, a trigger. What starts the work? A schedule, a new support ticket, a failed test, a change in the database. Second, it needs a goal. What is the loop trying to accomplish? And third, it needs tools, permissions. What is the agent allowed to read, change, send, and approve? Fourth, it needs verification. How does the system know whether the work is correct? Fifth, it needs memory. What has already been tried? What work still needs to happen? Sixth, a stopping rule. When should it finish? Pause, retry, or call the human. The final part is what people often miss. Make this better is not a good stopping condition. A good one is all tests have passed, security reviews complete, and the performance is within the agreed upon threshold. That is a good goal. A loop is only as good as the definition of done. Persistent goals in current coding agent systems specifically should be about what becomes true, how success should be checked, and which constraints must remain intact. This does not remove the human, it moves the human. Your job shifts from being the person who gives every instruction to the person who designs it. The object, the boundaries, the quality standard, the escalation points. You move from AI operator to my favorite, AI orchestrator. Okay, one quick pause. If you want my weekly breakdown of what is actually changing in AI without the hype, join my newsletter. I take the latest research, technology shifts like this one, and turn them into practical takeaways from leaders and builders. The link is below. Now let's get back to where loops become useful outside of software engineering. Okay, so do you need to be a software engineer to make this idea practical? There are 7 common loop patterns. 1, a schedule loop. Every morning, an AI checks your industry, identifies meaningful developments, verifies sources, writes a brief, and then sends it to you when something important is changed. 2, an event trigger loop. A customer complaint arrives. The AI gathers the account history, checks company policy, drafts a resolution, and escalates anything outside authority. 3, A goal loop. Give the AI a measurable objective, such as find the test suite, and then let it continue the completion of the condition until it's satisfied. 4, the system reviews past outputs. Compress them against feedback or performance data, identify weaknesses, changes in the process, and then test it again. The pattern is the same. You observe, detect, act, verify, and repeat. This is why loop engineering is bigger than coding. A measurable loop could search for new studies, evaluate source quality, compare findings, update a research database, and alert the researcher when the evidence changes. A contact loop could study performance data, identify topics your audience cares about, produce ideas, score them against your brand standards, and then send them to the strongest options for a human editor to review. An operations loop could watch projects for delays, missing updates, contact the appropriate person, update the project system, and escalate risk before the deadline is missed. A customer support loop could investigate an issue across several systems, recommend resolution, verify the action was completed, and continue to follow up until it is closed. The breakthrough is not that AI can complete one task. It's that AI can examine the result of a task and decide what should happen next. This is also, though, where loop engineering can become very dangerous. First, mistakes can compound quickly. A bad first decision becomes the context for the next decision, and soon the system is confidently moving in the wrong direction. Second, costs can run away quickly. A loop without a budget or stopping condition can consume enormous amounts of tokens and compute. And third, the AI optimizes the wrong measurement. If you tell a customer support loop to work on tickets as quickly as possible, it may close tickets without actually helping customers, doing its job, but the wrong job. Fourth, permissions can be too broad. Reading a system is very different from deleting records, sending payments, or contacting customers. And fifth, humans can just, stop paying attention. Attention does not remove accountability. The more autonomous the loop becomes, the stronger the verification, permissions, and escalation rules have to be. Long-running agent guidance warns that context management alone is not enough, and current containment work emphasizes limiting an agent's parental radius and boundary controls. So here's the question I would ask any repeatable part of your work. Does the AI have to wait for me to tell it every step to do? Or could I define it? What starts the work? What does good actually look like? What tools can it use? How can it check itself? And when must it come back to me? When you can answer those questions, you are no longer just writing prompts. You are engineering loops. Prompt engineering taught us to give AI better instructions. Context engineering taught us how to give AI better information. And loop engineering teaches us how to design better systems around AI. And that may be the biggest shift and improvement of all. Because the future of work with AI is not going to be humans typing and more prompts. It's going to be humans deciding the goals, setting the boundaries, defining what good looks like, and building systems that can keep working until the job is actually done. So don't just prompt AI. Start designing loops. I'm Sadie St. Lawrence, an AI researcher and executive with over 15 years of experience. And if you like this video, be sure to like, subscribe, and follow along for more AI education.